Next up, we have Stephen Potter. He's presenting the Intelligent Observatory, or the South African Astronomical Observatory. Peter, Stephen, the floor is yours.
I'm an astronomer at the South African Astronomical Observatory. I also hold a visitor's position at the University of Johannesburg. And before I begin, I'd just first of all like to thank the organizers for giving me the opportunity to speak to you all today. And I'm going to talk to you, I'm going to present to you a project we have ongoing at the South African Astronomical Observatory called the Intelligent Observatory. This is in fact a joint program between the SAAO and the South African Radio Astronomical Observatory. So there are four parts to my presentation. I'd first of all like just to start, set the scene behind the Intelligent Observatory by describing to you SAAO's part in the gravitational wave GW170817 event in 2017. So as you may remember, this event, which resulted in gravitational waves being detected at the LIGO Virgo Observatory, was as a result of the merger of two neutron stars. But what was unique about this event was the fact that not only were gravitational waves detected, but a couple seconds later, short gamma ray bursts were detected independently by the Fermi and integral spaceborne satellites. So this then was preceded by a worldwide effort to identify if there was any optical counterpart to this event. And it was the Schwope telescope that first identified the optical counterpart. And then once those the coordinates of those optical coordinates were made known, there was a worldwide effort to follow the course of this event. And that's what we did at the SAAO. So this image on the left is an image made with our 1.9 meter telescope at the observatory in Sutherland. You can see there's the optical counterpart and the host galaxy. And the image on the right is an image taken again with a 1 meter telescope, but 2 days later. And you can see just after 2 days, the optical counterpart was no longer detectable by a 1 meter telescope. We also have an infrared facility in Sutherland, and this continued to follow the optical afterglow at infrared wavelengths. And you can see, here's the infrared image on the right, there's the infrared counterpart. And even though this is a modest sized telescope, this demonstrates quite nicely the importance of multi-wavelength astronomy, because even though the optical counterpart had disappeared quite rapidly over just 2, 3, or 4 days, there was infrared light visible for almost pretty much 2 weeks later, even for a modest-sized telescope like that. And then, of course, at Sutherland, we also host the Southern African Large Telescope, and we were one of the first observatories in the world to obtain an optical spectrum of this event. And this optical spectrum was combined with other spectra taken from other observatories across the world to follow the spectroscopic evolution of this event. And then all these observations were finally combined to make the first so-called multi-messenger observations of a binary neutron star merger. And the thing I'd like to highlight here is this publication consisted of over 3,600 authors from over 700 institutes. And this is a clear demonstration of how important this multi-messenger event was, and also how much coordination and collaboration it took to get all these observations together to make the final scientific publication. So that sets the scene. So what's this got to do with the Intelligent Observatory? So I'd like to talk about the vision behind the Intelligent Observatory, why, what, and how this is all about. So in a nutshell, the reason why we're doing this is because we basically want to better serve the community and users of all our facilities in Sutherland. But this not only means, I'm not only talking about individual astronomers here, I'm talking about the plateau providing a service to other facilities, such as the LCO, or the Gaia satellite, or the Gamma Ray satellite, or the LIGO Virgo observatory, for example. So we want to provide a better service to everyone and everything. So what exactly is it? So basically what we're working towards is having all of our telescopes on the southern plateau integrated into an overall intelligent observatory, and thereby allowing us to better coordinate science across all of these telescopes in the so-called era of multi-messenger astronomy. And that will enable us to respond better to alerts and other computer-generated requests. And it also requires us to automate a lot of these processes, and not just telescopes and instrumentation, but also the management of proposals and things like that. So basically, this program is advancing the SAAO into the so-called fourth industrial revolution. So how will we do this? How are we doing this? So there are kind of four overall work streams. The first being consisting of all the hardware and software upgrades that we'll need to do. So for example, our telescopes and facilities, in particular our own workhorse telescopes, we need to upgrade the hardware, the electronics and software so they become more automated and more robotic. Another work stream will be the data science software services that we provide. So rather than providing recipes for data reduction, we'll need to upgrade the software such that observations from telescopes will be automatically processed through pipeline solutions, so in order to enable quick look on-the-fly data analysis. A third category would be the kind of intelligent algorithm aspects of the Intelligent Observatory. So this will be the software algorithms that will make intelligent decisions behind things like alerts that might come from LSST or Meerkat or the LIGO Virgo facilities, etc. And then finally, the fourth work stream is that we're going to have to overhaul the complete management of astronomy operations and telescope operations across our facilities in Sutherland to better accommodate the vision behind the Intelligent Observatory. So I just want to talk about the sort of telescopes that briefly talk about the sort of telescopes we have in Sutherland, just to give you an idea of the challenge that we have behind us. So we have, there's kind of three workhorse telescopes that the SAAO fully owns and is available to the whole international community. There's two rather old telescopes. There's the 1.9 meter telescope is over 70 years old. We have a 1 meter telescope that's about 50 years old. And we have another new 1 meter telescope, which is about 4 or 5 years old. And between them, they have a suite of instruments that are capable of spectroscopy, polarimetry, imaging, and a speciality of ours has been high-speed imaging. We also host, of course, the Southern African Large Telescope. The SAAO for the National Research Foundation is a partnership in this facility, and this is a Q-scheduled surface observing telescope. And in addition to these 4 telescopes, we have a range of other telescopes. Some of them we purely host, they are fully automated or robotic, and some of them are partnership telescopes, like for example, the infrared facility is a partnership between the SAAO and some institute in Japan. Okay, so the final section of my presentation is, where are we in this vision right now? What is our current status? So at the beginning of the program, we were in a situation where if you wanted to use the facilities in Sutherland, you either had to go to Sutherland yourself in order to use those workhorse telescopes that I described earlier, or you would contact, say, the LCO network to use submit proposals to the LCO telescopes, or if you're you would have to contact the other host facilities if you wanted to get time on those telescopes. Since the project has begun, we have now upgraded all of our workhorse telescopes, even the telescope that's over 70 years old, such that now we provide remote observing capabilities. And now we can control these via software. There's no reason now that we can move beyond just humans remotely operating these telescopes, but they can be robotically or automated in some way. So the next step that we're working on now is making these facilities as a service that are not only available for astronomers, but also to other facilities in general. So for example, the Vera Rubin telescope through the LSST program will provide an alert service. So we will want to enable the Intelligent Observatory will intelligently analyze those alerts and send requests to an appropriate suite of telescopes to do follow-up. The same goes for the LIGO Virgo alerts and also other spaceborne systems like the gamma ray observatories and perhaps and also the Gaia facility as well. So to do this, we're building what we're calling a central control system. And at the core of this central control system is going to have to do all these sort of things. So this is just a list of what I've already described. For example, there's one telescope, this one over here, called MIRLICT, that will simultaneously obtain an optical image of wherever the MeerKAT telescope is coming from. So if this telescope in real time detects an interesting optical counterpart to a MeerKAT radio transient event, it would then send an alert request to our central control system to maybe obtain a spectrum from using the SALT telescope or polarimetry using the SALT telescope, or maybe to continually follow it up with high-speed photometry with one of our 1-meter telescopes. So that brings me to the end of my presentation. If you'd like to know more about the Intelligent Observatory, there was a rather nice write-up in Physics Today earlier this year. We also have a website where you can obtain more project-orientated information. And also there's my email address if you'd like to know more. And that's my presentation. Thank you very much for listening.
All right. There is, okay, so I think Peter asked a question. I think you addressed that. So he asked, so there's so many telescopes near each other, and look at this cute stereo all-sky gadget. So, and I see you responded to him there. There are sky brightness monitoring cameras, and yeah, so there are 2 of them apparently. So Ruby asks, here on Discord, Steve, can you comment on the future vision of trying to, in the partner telescopes, on the plateau towards building multi-wave astronomy in SA?
Yeah, that's a very good question. Thanks for that. Yeah, so one example that I gave during my talk was linking up with the MIRLICT telescope, as you know, which simultaneously monitors the sky with MeerKAT. So there's the multi-wavelength connection there. And also we're going to try and offering to link up with any facility around the world as well. So we're part of the kind of in-kind contribution to the Vera Rubin Observatory. So part of this Intelligent Observatory project is to make the observatory AON compliant, such that we can better connect into their alert services and to their scientists as well.
Thank you. I see Peter is typing another question here. Just posted that. Okay, so perhaps stereo, so you can see the clouds in 3D. So I'm not kidding. We have a single all-sky camera, and we can see clouds moving at different heights in different directions. I guess this could mean something for the quality of the night. So just comment.
Great, thanks. Yeah.
Thank you so much for the talk.
Right, thanks everyone for listening.